Okay, this question says, let f be this function defined by f of x equals 2x plus 3e to the negative 5x. And g is a differentiable function with derivative g prime equal to this. It's known that the limit as x goes to infinity of g of x is equal to infinity. Find the value of this limit here. So they're kind of throwing a jumble of information to us. But let's just take a look at this limit and first notice. Okay, so like if we meet this limit head on, we might first note that f of x has like a concrete description. It's 2x plus 3e to the negative 5x. Now g of x doesn't have a concrete description or an explicit form. We have its derivative. So I'm just going to leave this as g of x for now. Okay. So can we evaluate this limit as is? Well, one thing to note, this shows up in like textbooks as like properties of limits, but the limit of a fraction is the limit of a fraction is the fraction of the limits. I guess that's the way of saying it. In other words, I can like do this problem as though this is what I want to do, assuming the denominator doesn't end up being 0. And so now what's going to happen here, we're told that, like we're just told this fact, that just kind of this fact is there for a reason. So this denominator is 0, infinity rather. And if you look at the numerator, as x goes to infinity, the numerator also goes to infinity because 2 times, as x goes to infinity, you're getting, this part's going to 0, right? Because e to the negative 5x is the same as 1 over e to the 5x. So that expression gets smaller and smaller. But you still have this here, which is 2 times infinity, 2 times a really big number. The point, all this is to say, this is ending up being a L'Hopital's rule problem because that's an indeterminate form. And so we can use L'Hopital's rule. And we get, so now, again, maybe I'll just go back to this representation. So L'Hopital's rule says take the derivative of the top. Okay, the derivative of the top is 2. And then the derivative of 3e to the negative 5x is 3e to the negative 5x times negative 5. And then the derivative of the bottom is the derivative of g of x. We're told what that is. They tell us that here. That's this. Okay, and so now what? We're going to try to evaluate this and see what happens. So as x goes to infinity, what happens here? Okay, and mainly what we care about is what happens here, right? Like what's going to happen to that expression? Well, that's going to go to 0 because negative 5 times infinity is, again, a really big negative number, and e to a really big negative number is 1 over e to a big number, and that's, maybe I'll just indicate that, that's essentially 0, right? So this is like 1 over e to the 5 times infinity, that's essentially 0. Okay, so that vanishes. So I'm left with 2 plus 0 in my numerator. And what about the denominator? Well, as x goes to infinity, this expression goes to 0. And this goes to 4 times cosine of 5 over infinity. But 5 over infinity is approaching 0. So our denominator is approaching 0 plus 4 times cosine of 0, which is 4. So this ends up in the end being 1/2. So they made us work for that. 1/2 is b. Okay, they kind of gave us information in all this fragmented way. But the overall principle here is like if you're giving a limit and we're going to infinity or 0, you're probably in the world of using L'Hopital's rule.